Okay. Okay, beta. So this is the new topic that is added in the syllabus this year. So it's about charging and discharging a capacitor. What we'll be looking at is we'll be looking at quantitative analysis of charging a capacitor. Like before we go into the topic, so let me tell you one thing कि जो हमें already पहले से पता है, like this is a parallel plate capacitor, ठीक है? And if it is not charged initially, it is neutral, then it means that positive and negative charges are equal in amount on it. There is no charge distribution over it. But when you connect this with a battery, or battery should be according to the rating of the capacitor. Let's say if rating of this capacitor is 20 microfarad and 3 volt. This is capacitor rating. It means that the maximum voltage that you can supply to this capacitor is 3 volt, or its capacitance value is 20 microfarad. So let's say I'm connecting it with 3 volt battery. So what's going to happen is कि यहाँ से the electrons are going to move from negative terminal of battery towards one of the plate, and let's say that plate is Q. So what will happen is that these electrons will start shifting on this plate. So these are the extra electrons. Now these electrons are going to repel the electrons in plate P. So electrons in plate P will be removed off and they will be moving towards positive terminal of the battery. After some time, what will happen? After some time, this capacitor is going to be charged. So this is like positive charge and this is negative charge. So this is known as a charged capacitor. This is a charged capacitor. Okay, and battery does work to charge it, right? Acha, ab jo work done by battery hai, that will be equivalent to 1/2 QV, where V is the potential difference between the two plates, and then Q is the charge on any one of the plate. Like both the plates will be having same charge but opposite sign. So Q will be value of charge on any one of the plates. Okay. So the work done by battery to separate the charges is half QV, or it can be half QC square, because you know Q is CV. Q is CV, right? So sorry, it's not QV square, it's CV square, half CV square, half CV square, right? Because Q is CV now, so you just replace this Q with CV. So it will be CV square. So this is another formula to find energy stored in the capacitor. Now the question is how this capacitor is going to be charged, or how this is going to be discharged, and we need to look upon some technical terms related to it, such as time constant. Acha, ab sabse pehle let's just read the syllabus points. You have to analyze the graphs of the variation with time of potential difference, charge and current for capacitor discharging through a resistor, right? So when a capacitor is discharging now, to how its potential difference across plates V is changing with time, how the amount of charge on it is changing with time, or how the current flowing through circuit is changing with time, to hum uske graph banayenge. Then we will recall and use. When they say recall and use, it means it's a very simple term. It's not technical term. It's straightforward, simple thing. Recall and use. Recall. We don't have to derive it. So they will give this equation. Recall and use T equal RC. T is time constant. R is resistor through which capacitor is discharging, and C is capacitance of that capacitor. So time constant is RC. For a capacitor discharging through resistor. So this is the new term, number 2. Then we have to use the equation which is x equal x naught e power minus t over RC. This is exponential equation. X and x naught kya hoga? X and x naught can be potential difference, it can be charge, it can be current, right? So x is a journal symbol. You can replace any 3 over there. T, small t. What is small t? अब अभी हम सिर्फ सिलेबस में पॉइंट्स में इसको देख रहे हैं, आगे तो डिटेल में देखेंगे ना. So what is small t? Small t is the time in which the quantity x changes from x naught to x. मतलब पहले x नॉट है ना, वोल्टेज लेट्स से v नॉट है ओरिजिनल, फिर वो v हो गए, तो v नॉट से v होने में जो टाइम लगेगा वो स्मॉल t होगा, राइट। इसी तरह अगर करंट है तो करंट I नॉट से I होने में जो टाइम लगेगा वो क्या होगा, small t, उसका टाइम small t होगा. What is R? C, R is the resistor through which capacitor is discharging and C is its capacitance. So where X could represent current, charge or potential difference for a capacitor discharging through resistor. This was the only leftover thing, these 3 points. बल्कि इसमें से first point तो we are already done with first point, लेकिन उसको हम दोबारा भी देख सकते हैं. So let's see capacitor discharge graphs. So whenever a capacitor is discharging now, so what's happening is okay, one of the plate is losing its charge. So let me quickly make a charge capacitor. So let's say this is a charge capacitor. One of the plate is having positive charge, the other is having a negative charge, and let's say you have connected it across a resistor with a resistor. So what will happen is that these electrons are going to move through this resistor, and these will be going towards the positive plate in order to neutralize it, right? So when the electrons will start passing through resistor, so their speed of movement will be different. Initially, like if you keep one switch over there, so if initially switch is open, so no electrons are moving, but as soon as you closes the switch, so what will happen? Electrons will quickly move from one plate towards other plate, like from plate 2 to plate 1. तो शुरू में इलेक्ट्रॉन्स बहुत ज्यादा होंगे, बाद में बाय द टाइम इलेक्ट्रॉन्स का फ्लो कम होना शुरू हो जाएगा, और ये एक्सपोनेंशियली कम होगा, एक्सपोनेंशियली, नॉट लिनियरली, एक्सपोनेंशियली. दैट्स व्हाई इसका जो हमने ग्राफ बनाया था, इफ यू रिमेंबर करंट टाइम ग्राफ, तो करंट टाइम ग्राफ जो है वो एक्सपोनेंशियल बना था. शुरू में 0 टाइम पे करंट मैक्सिमम है, और फिर ये डिक्रीज होता जा रहा है, और फिर आगे जाके एक पॉइंट पे वो 0 हो जाएगा. So this is the current time graph for a capacitor discharging through a resistor, and it is exponentially decreasing. That's why इसकी जो इक्वेशन होगी यहाँ पे शुरू में ये I नॉट होगा, ये होगा I इक्वल I नॉट e पावर माइनस T ओवर RC. ये एक्सपोनेंशियल इक्वेशन जो है ये एक्सपोनेंशियल ग्राफ के लिए होती है. Okay, so if we just read through it, so what's written that so far only capacitors charged by battery have been considered. This is when electrons flow from positive to negative plate. At the start, when the capacitor is charging, the current is large, and then it gradually falls to 0. So charging के लिए भी ये होता है कि शुरू में current, ये जो ग्राफ है ना, this graph is same for charging and discharging of capacitor. Same. Like जब चार्ज होता है तब भी ऐसे ही होता है, और डिस्चार्ज होता है तब भी ऐसे ही होता है कि शुरू में करंट हमेशा ज्यादा होता है, बाद में करंट ग्रेजुअली डिक्रीज होता है, and when capacitor is fully charged, no more vacancy for the charge, the current becomes 0, even if it is charging, even if it is discharging. So same graph. Okay, capacitors are discharged through a resistor, we know that. The electrons now flow back from negative plate to the positive plate until there are equal numbers on each plate. As I told you that electrons in this circuit are moving from negative plate to positive plate. At the start of discharge, the current is large, but in opposite direction to when it was charging, and gradually falls to 0, right? Okay, again, this is the circuit. This is the battery which is going to charge it, and this is the capacitor, and then a micro ammeter is there, sensitive ammeter that will detect the current, and this is the resistor through which the capacitor is going to discharge or charge. So what you will do is, this is the switch. If you connect it with P, so what will happen? Capacitor is going to charge. So charging process will happen, right? If this is connected with P. So when charging will happen, then electrons will be moving towards the capacitor through the resistor. And when the resistor is fully charged, and then what you do is you connect this switch to Q. So when you connect this with Q, what will happen? The current will move like this, and it will be a discharging cycle now. The capacitor is going to discharge through the resistor. It's just the illustration of what's going to happen. Now the graphs, we need to talk about the graphs. So all 3 graphs, like the first graph is the current during the discharge, second is the voltage, and the third one is charge. All 3 graphs look similar, and we have done that in the class. कि तीनों जो ग्राफ्स हैं ये एग्जैक्टली सेम होते हैं एक्सपोनेंशियल डिके कर्व की तरह. दैट्स व्हाई दे हैव सेम इक्वेशन x इक्वल x नॉट e पावर माइनस टी ओवर आर सी, बिकॉज सबकी शेप सेम है. एक्सपोनेंशियल नेगेटिव माइनस टी ओवर आर सी है ना, क्योंकि ये नेगेटिव डिके. अगर ये कर्व पॉजिटिव होती तो ऊपर फिर प्लस टी ओवर आर सी होता, राइट. Okay, so as the capacitor discharge, the current, potential difference and charge all decreases exponentially. This means that rate at which current, potential difference or charge decreases is proportional to amount of current, potential difference or charge that has left. So this is really important कि जो चार्ज जितना बाहर आ रहा है, जितना करंट फ्लो कर रहा है, वो डिपेंड कर रहा है किस पर के पीछे कितना रह गया. बिकॉज अगर पीछे ज्यादा होगा तो वो ज्यादा पुश करेगा. Let's say if too many charges are there on the plate, so they will push with more force to the charges that are going out. But if remaining charges are less, so of course they can't push the going away charge with more force. That's why this is exponential decay, right? Like this one, यहाँ पे देखो slope steep है, but it is getting less steep. Why? Because the remaining charge is decreasing now. So that's why it can't push the outgoing charge with greater force. Okay, the graph of variation with time of current, potential difference and charge all have identical and represented by an exponential decay. So this is exponential decay graph. Okay, so what are the key features of the graph? I have already told you, so just go through it. The shape of current, potential difference and charge against time graph are identical, same. Each graph shows exponential decay curves with decreasing gradient. The initial value start at the y-axis and decreases exponentially. Same thing again and again. The rate at which capacitor discharges depend on resistance of the circuit. Now, this is important thing. The rate at which capacitor discharge depends on resistance of the circuit. Resistance kitni hai? This makes sense. If the resistance is more, then less current will be passing through it. We know I inversely proportional to R. If the resistance is high, the current will decrease and charge will flow from capacitor plate more slowly, meaning the capacitor will take longer to discharge. So see, for a capacitor to discharge, the one of the important thing is resistor itself, which you have connected with it, जिसके cross उसने discharge होना है. Okay. एंड कैपेसिटेंस भी मैटर करती है. अब देखो एक कैपेसिटर अगर बहुत बड़ा है, उसकी वैल्यू बहुत ज्यादा है, वो फुली चार्ज है, और एक कैपेसिटर छोटा सा है, उसकी वैल्यू कम है, वो फुली चार्ज है, तो जल्दी डिस्चार्ज कौन सा होगा? शॉर्टर वन, जो स्मॉलर चार्ज है जिसके ऊपर. ऐसे ही है ना, राइट? क्योंकि उसके पास एनर्जी कम है ना बेटा. जिसके पास कम एनर्जी है वो जल्दी डिस्चार्ज हो जाएगा, जिसके पास ज्यादा एनर्जी है, इट विल टेक मोर टाइम फॉर दैट टू डिस्चार्ज. सो दिस इज अगेन अ कॉमन सेंस. So the thing is, two things are very important in discharging time for a capacitor. One is the resistor which is connected with it, and second is its capacitance. So when you multiply both of them together, R and C, so you get a specific term which is known as time constant. क्योंकि ये दोनों टाइम, मतलब इन दोनों की वैल्यू पे टाइम डिपेंड कर रहा होता है. Discharging time depends on R, discharging time depends upon C as well. So bigger R से क्या होगा? Low current, so it will take more time for capacitor to discharge, and then at the same time bigger capacitor mean more amount of charge stored, more energy stored. It means longer it will take to discharge. So that's why we say product of R and C determines the time in which the capacitor is going to discharge. What is inversely proportional? No, directly. Like bigger R, bigger R, no, bigger R, bigger T, bigger R, bigger T. Yeah, bigger R, bigger T. Okay, that's gone. Okay, but we'll continue with it. Okay, so the thing is, actually we don't discuss the background of an equation. Like actually T is RC, so how that has developed, that took a long time for the scientists to develop that. Even E equal mc squared, that looks simple, but there is a complicated derivation behind that, right? So we at this stage we don't look upon that thing, no? So that's why. Okay, so okay, I was going to tell you Must be coming. That RC affects time for discharge of capacitor. But how? Can you tell me the unit for R? What's the unit for R? Ohm. And then if you break it to SI units, R is like V over I. R is V over I. And C is capacitance, and capacitance is Q over V, है ना? Okay, then V to cancel हो गया. And this Q is IT over I, so I gone, so it is equal to T, which is second. So the thing is, the unit of RC is equal to time. So that's why we say this RC is actually time constant. Okay? Okay. So let's move to next, the time constant. अब time constant I've already told you, so let's just go through it. इसकी definition थोड़ी सी different है. It's not the time taken by capacitor to fully discharge. No, it's the time taken by capacitor to charge by 62%, 62.8% of its total capacitance. It's not because like we look this in the graph, because of the exponential decay curve. If it would be linear, तो ये हम total time बता देते. Because it's exponential, so it will take too long for that capacitor to discharge. So what we do is we divide that in different fractions, right? Because of exponential. So just look at it. The time constant for a capacitor discharging through a resistor is measure of how long it takes for a capacitor to discharge. The definition of the time constant is the time taken for a charge for charge of a capacitor to decrease to 0.37 of its original value. Decrease to 0.37, but there is another way to state this. So what's the another way? Huh? Decrease to 37%. Okay, एक और भी होगा. Yes, decrease to 37 means if it is having 100% charge, and how long will it take कि पीछे remaining कितना रह जाए, 37 रह जाए. So it means कि how much is gone? 63% is gone. Actually it's 62.8, but we round off करके 63 करते हैं. So we can also define it as the time constant is defined as the time taken for a capacitor to charge to 63% of its total capacity, or time taken by capacitor to discharge by 37%.